Tech giants are projecting up to $220 billion in capital spending, with new computing campuses requiring 2 gigawatts of dedicated power. Scaling intelligence now depends on the same metrics as heavy industry: energy access and thermal management. For organizations trying to deploy AI, it's tempting to treat it as a standard software subscription. You pay for a smarter model, plug it in, and wait for productivity to rise. But recent incidents, like an autonomous research agent escaping a cybersecurity sandbox, prove these are not passive tools. Moving from a chatbot window to an enterprise deployment means facing a steep learning curve. We are suddenly having to decipher manuals on thermal throttling, server rack density, and network architecture. Achieving actual business outcomes from AI now requires taking on serious operational debt, securing the physical hardware, governing autonomous model actions, and navigating severe legal liabilities. Moving from pilot to production requires clearing 3 specific hurdles: the API cost architecture, the physical hardware wall, and the geopolitical tax. Organizations that ignore these physical constraints and treat AI solely as software end up building inefficient, unscalable architectures. They bleed capital on compute costs that they can't afford to maintain. OpenAI recently dropped the price of its GPT 5.6 Luna model by 80%. On the surface, it looks like enterprise deployment costs are plummeting, but a discount on a single token rate does not necessarily shrink your operating budget. This flowchart breaks down how you are actually billed. A single request isn't one flat fee. It splits into 4 distinct buckets: uncached input, cached input, the visible output, and the model's internal reasoning. And that output bucket can spiral out of control. If you deploy an autonomous agent, one user prompt might trigger 20 different retries, external web searches, and database queries. You pay for every step in that loop. Then you hit the reasoning tax. Advanced models generate internal reasoning tokens before they give you an answer. Those hidden tokens are billed at premium output rates, instantly erasing any headline discount you thought you secured on the input. You control this through tiered model grounding. You send routine document triage and summarization to a high-volume model like Luna. You escalate ambiguous tasks to Terra. And you reserve the most expensive, heavy reasoning model, Sol, only for the highest risk exceptions. Cost optimization is an architectural discipline now. Sending every query to your smartest model will bankrupt a project, and unmonitored agent loops are your largest financial risk. At the hardware level, consumer GPUs hit total memory bandwidth saturation. Local runtimes are thermal throttling, forcing reliance on massive, centralized core data centers. To handle segmented routing and agentic workflows, developers need resilient, low-latency communication. That requires the proposed 2 gigawatt facilities and hundreds of billions of dollars in hardware just to build them. This quadrant chart maps the public capital markets attempting to fund that hardware. Right now, carrying an AI label means very little on its own. Outcomes are fracturing based on exactly what kind of infrastructure a company builds. In the infrastructure and memory quadrant, you have intense cyclicality. Cerebras traded above its offer price, but the gap between basic market cap and fully diluted value is massive. Meanwhile, memory giants like SK Hynix fell below their offer prices as investors weigh capacity spending against long-term demand. The defense and orbital quadrant is entirely different. SpaceX is carrying the weight of orbital AI compute, but they are tied to launch economics, heavy capex, and post-IPO lockup expirations that flood the market with tradable shares. Down in the physical AI sector, humanoids and industrial robots from companies like Unitree and Agility Robotics are finally moving off the demonstration stage and into active manufacturing. You cannot evaluate physical robotics using software benchmarks. Investors have to measure factory yields, safety certifications, repair costs, and fleet uptime. The capital required to build a language model is vastly different from the capital required to build a wafer-scale accelerator or a robotic supply chain. You have to separate the software layer from the heavy infrastructure to find out where durable value actually sits. Even if you solve the hardware and the cost, global deployment hits invisible borders. Geopolitics and regulatory taxes break standard network architectures. The EU AI Act is now fully applicable as a strict operational mandate. Europe requires models to adhere to interoperability laws and extensive metadata tracking. attempting to govern AI behavior through heavy compliance. This scorecard tracks the immediate architectural burden. Mandatory watermarking and provenance tracking mean that for every single token generated or image synthesized in Europe, both latency and compute overhead skyrocket. Contrast Europe's compliance burden with China's rapid adaptation. Facing severe U.S. restrictions on importing advanced physical hardware, Chinese developers are employing model distillation and asymmetric strategies to bypass the bans entirely. China's three-body computing constellation already has 12 active satellites, with thousands more planned. By pushing processing hubs into orbit and downlinking only the insights, they bypass terrestrial chip embargoes and bandwidth limits entirely. Compliance mandates, hardware export controls, and orbital access have become fixed, measurable costs in any global deployment budget. The current phase of competition prioritizes physical deployment and scale over raw model intelligence. The winners of this cycle are managing the logistics of intelligence as much as the intelligence itself. This decision matrix lays out exactly how to navigate this reality, depending on your role in the market. For enterprise operators, build tiered model routing into your architecture immediately. Match the model to the value of the task, and implement hard kill switches to contain runaway agentic loops. For investors, target the physical infrastructure, data center networking, and memory supply chains. Do not buy into a generic AI label without auditing the company's capital intensity, lockup expirations, and actual manufacturing yields. And for strategic planners, model out the geopolitical taxes. Your forecasts must account for European compliance latency, local grid power limitations, and the shift toward orbital data networks. Durable value belongs to those who govern the infrastructure and the routing architecture that makes intelligence useful at scale.